Okay, this system of equations, it's actually really fun because you can see how similar they look, right? And in fact, when I first saw this system of equations, I thought, okay, this system of equations, it's actually really fun because you can see how similar they look, right? And in fact, when I first came up with this system of equations, I thought it has no solutions because I was thinking and also hoping that maybe x is just equal to 4 and this part is just equal to 0 because that we can get 4 plus 0, we get 4. And we see 1 over y is equal to 0. This actually has no solutions. You cannot find a number so that you do 1 divided by that number, you get 0. Not possible. And in fact, if you want to say the answer is infinity, that does not satisfy this equation either. Infinity plus 1 over 4, it's not equal to 4. Yeah, but anyways though, thought about it for a little bit longer. This right here, it's actually really nice, and of course it does have solution. Let me show you how it is. So notice how similar this part is. It's just that here we have x, but this is y, and here we have y, but this is x. In order for this to be true, the only case that we have to consider is that y has to be the same as x, and that's the key for solving these equations. And here's the idea though. Imagine if you have some input, let's call it t plus 1 over t. That function is what we call 1 to 1. What it means is that if you have the same output, that means they must come from the same input. So I can also show you guys like why this is true by doing more algebra. Have a look. If you look at the first equation, multiply everything by y, then we get x times y plus 1 because the y's cancel, and then 4y, and multiply the second equation by x. We get xy plus 1, and that's equal to 4x. And you see this part and that part are equal, so that means this and that has to be the same. So we get 4x is equal to 4y, and of course divide both sides by 4, x has to be the same as y. And this is why that this is the only case that we have to consider. Now we can just solve it. Maybe look at the first equation and say x plus 1 over, don't put down the y, put down the x. And then we get 4. And then multiply this equation by x. We get x squared plus 1 is equal to 4x. Now we have a quadratic equation. I will move this to the other side, but that's not going to be factorable because now we have the coefficient of the x is even. I will complete the square. So I'm actually going to keep the x squared here, bring this to the other side, leave a space, and bring the 1 to the other side. Now, how do we complete the square? First, we make sure we have a 1 in front of the x squared, which we do. Then, we take half of this coefficient, and then square that. Half of negative 4 is negative 2. Squaring that, we get positive 4. This is the magic number. This is a number that we have to add both sides. It also magically appears. And now you can see that if you factor the left hand side, you get x minus 2 times x minus 2, which is just x minus 2 squared. And for this, negative 1 plus 4 is positive 3. And then just go ahead, take the square roots both sides. Don't forget the plus minus. Get rid of this. X minus 2 is equal to plus or minus square root of 3. Add 2 to both sides. We get x is equal to 2 plus or minus square root of 3. So it has two possibilities. And remember, we also have to get a y, but y is the same as x. So in fact, this is it. We can say when x is equal to 2 plus square root of 3, y is the same thing. Or the other possibility is when you have 2 minus square root of 3, y is again the same thing. So we have these two sets of solutions, and that's it. Well done. Pretty cool, huh? And you want to see why we are doing this right here for completing a square, you guys can check out this video for it. That's it.